Hi guys, welcome to Math1141. So for this tutorial, I will talk about Math1141, chapter 2, question 11, X question. So now let's look at question. A point P in Rn has a coordinate vector P and find the coordinate vector of the point Q, which in a reflection of P in a line L which pass through the point A and parallel to the direction D. Okay, for this type of question, firstly we need to draw the picture. So while after you draw the picture, you can see very clearly solving step. So now let's draw it out. So we have the point P. So we draw a point position vector P. So it have position vector P. And we have point A. So it have position vector A. So we write point A, we have position vector A. So this is origin. This is position vector A. And we got a line L in direction of D and pass through A. So this is a line L and equal to point A pass through the direction of D. So the vector of this is D. Okay. Now we got the point Q. Q is the reflecting point of P by this line L. So we can put a point Q in here. And Q have the position vector of Q. Okay. So firstly, we need to look at this picture and see what can we get. Obviously, PQ, the vector PQ must perpendicular to the direction of D because it's reflecting. So we draw PQ up. So P to the Q must perpendicular to this line L. Okay. So how do we find position vector of Q? We can find out this vector first. This vector PQ first, and then we can pass PQ vector with position vector P. We can finally find the position vector of Q. So this is our basic strategy. So now let's see how do we going to find PQ. Don't forget, we got another point A. So just for out of interest, we can draw this point. Now you can see something. If we put vector AB here, and here is a line with direction D. So can we find a, now we can put our points in here, we say D. Now, can we find the vector direction vector PD? Look at this. Don't remember this is right angle. Yes, of course we can. How? We can use the projection. Project AP on direction of D. We can find the PD. Then we double the PD. We find the PQ. Then final step. We just join up the OP and the PQ. We find the position of Q. So basically this is our strategy. So this is basically solve all the equation, but I will show out how to write it down. But you can stop here because if we just want to get some idea, you can just solve it out right now. So now we have OP. So OP is vector P. AP has vector P minus A. Obvious enough. So PQ. What's the PQ? We need to find the PQ first, right? So we need to find the PD. So how do we find a PD? Going to find a PD, we need this line and this line. Why? Because when we're doing a projection, we only can find out AD. We can't find out PD. So we need to find out AD and the AP, and then finally we can find out DP. Okay? So now let's find out of AD. So AD equal to project of AP on direction of D. Right? So on direction of D, now let's write out AP is P minus A. Direction of D divided by D squared with direction of D. So this is AD. Now how do we find the PD? We can use AD minus AP, we got AD, PD. So PD equals to AD minus AP right? So what's the AD? It's up here. P minus A dot D over D squared minus AP. So what's the AP? P minus A. Right? Now we got PD. We want PQ. So since PQ equals to 2 PD, of course it's vector. So it's supposed to be twice of this equation. So it's supposed to be 2P minus A dot D, or just for simplicity, we just write to project AB on D. We just this P minus A dot D divided by modulus D squared dot times vector D. We just write project AP on D minus 2P minus A. Okay, this is our PQ. Now we go into final step, find the Q. So what's the OQ? OQ will be point OP pass PQ, the vector PQ. So OP, what's the OP? OP is P, right? So PQ is to project AP vector on D vector minus 2 blah blah blah. So pass to project AP on D minus 2P minus A. Then we just simplify it. P minus 2P, we got minus P, minus 2 minus times minus A, we get plus 2A. Then pass 2 project AP on vector D. Okay, this is the end of the solution. So thanks for watching.